two is it three forces that are not perpendicular or parallel to the plane, right? Excuse me. So we have the horizontal component of the 3p newtons is in this direction, and then its vertical component is in this direction, right? And then the p newtons, its horizontal component is in this direction, the vertical component is downwards, right? Then for the 20 Newton force, the horizontal component is in this direction and the vertical component is downwards, all right? So resolving 3p newtons, right, vertically it means we have 3p sine 30. Then horizontally we have 3p cos 30. And then for p newtons, vertically we have p sine 30. Then horizontally we have p cos 30. Right, that one is not clear. Let me just work on this part. Right, this is 3p cos 30, all right. And then for the 20 Newton force, what it means is that horizontally we have 20 cos theta. Then vertically we have 20 sine theta. 20 sine theta. All right. So and now we need to make sure that we combine these forces, those acting vertical and then those that are acting horizontal. So you can now come down here and say consider the vertical forces or components. All right, so for the vertical forces, I'm sure you can see we have 4p plus 3p sine 30. They are going upwards, right? So it's 4p plus 3p sine 30, right? This must be equal to p sine 30 plus 20 sine theta. All right, we can try group like terms here. It's possible to do that. So this simplifies to, right, I'm just going to put a double arrow there. If I bring p sine theta on the other side, that means I have 4p plus 2p sine 30 equals 20 sine theta. Right, what is sine 30? Right, sine 30 is 0.5, it's half. This is 0.5. So that means here we're having 4p plus 2p times half equals 20 sine theta. Right, that simplifies to what? Right, 4p plus p equals 20, there is 20 there, sine theta. Right, then this is giving us what? 5p equals sine 20 sine theta, dividing by 5 both sides. Right, it means p is equal to sine theta. If you check very well, p equals 4 sine theta. All right, we can call this equation number 1. This was the vertical components. All right, so now let's consider the horizontal components. Consider the horizontal components, or you can call them forces there. Right, let's go back to our diagram. And so you can see with 3p cos 30 and p cos 30 to the left, and then 20 cos theta to the right. Right, so that means we have 3p cos 30, right, 3p cos 30 plus p cos 30 equals 20 cos theta. This gives us 4p cos 30. 4p cos 30 equals 20 sine, cos theta. Cos theta here. Then cos 30 is root 3 over 2. So we can try simplifying that, or we can first divide by 4 this side. Right, anyway, let's simplify that. 4p, and then this is root 3 over 2 equals 20 cos theta. Right, this cancels out and that goes, so I have p root 3p is equal to, here I have 2. Right, 2 root 3p equal to 20 cos theta there. Then we can divide both sides probably by 20, 2 root 3, right? Right. Or maybe we can just call this equation number 2. Then now that means we have 2 equations, okay, the ones that I highlighted earlier. So if p equals 4 sine theta and 2 root 3p equals 20 cos theta. Right, this is your equation number 1 and that's your equation number 2. There's so many ways of dealing with this, all right. I think the easier way to work out this thing is to divide the 2 equations. Equation 1 divided by equation 2. So if I divide equation 1 by 2, that means I'll have p over 2 root 3p on the left hand side being equal to 4 sine theta over 20 cos theta. Right, I want you to recall that sine theta over cos theta is equal to tan theta. All right, equals tan theta. So that means p and p cancel out this side. We have 1 over 2 root 3 equals 1 over 5 tan theta on the other side. So that means tan theta is equal to 5 over 2 root 3. Then theta is equal to arctan 5 over 2 root 3 there. Let's deal with that to see what value of theta we get there. So if arctan, right, arctan 5 over 2 root 3. This gives us what? Right, I'm getting 55.3 degrees. Correct to 1 decimal place equals theta. And now if you go back to this equation, we can find the value of p, right? So p is equal to 4 sine in brackets 55.3 degrees. This gives us what? Right. So this is 4 sine of the answer times, right, I'm getting 3.2879, which is approximately equal to 3.3 newtons. Right, so this is basically how you deal with this type of a question. Each time you come across this type of a question, Coplanar forces that are in equilibrium. So the key thing to do is to first resolve your forces. You have your horizontal components. Since the system is in equilibrium, you know that vertical forces will be equal and the horizontal forces will also be equal. So just take note of the directions and do the correct resolution of forces. Otherwise, this is how we deal with this one. I hope we got it right. See you next time, guys.